All right, greetings everyone. Welcome to the first part of the video for section 6.3. And as you might imagine from the meme you see here, now that we've had some time to talk about sine and cosine functions, as well as the functions related to the other trigonometric ratios, we're now going to start looking at inverses of these functions. So before we get into inverses specifically for these functions, let's first discuss what is an inverse function. And so do we recall, or maybe there was a hint on the slide that we just saw? Right, so an inverse function switches inputs and outputs. So as an example of that, if I had a table of values for this function that I'm going to call f of x, okay, and let's say that we had the values 1, 2, 3 as inputs and 4, 5, 6 as the corresponding outputs. Well, then an inverse function, or the inverse function, I should say, for this, the table for that would look like, well, we'll take the inputs of the original function will now become the outputs, and the outputs will now become the inputs. So now it'll look like inputs of 4, 5, and 6, and outputs of 1, 2, and 3. Okay, so again, an inverse function switches the inputs and outputs of a function. And if you recall also from whichever course you took before this one, that we know if a function has an inverse because it has to be one-to-one. Okay, if a function is not one-to-one, then it does not have an inverse. And the reason for that is because if the function is not one-to-one, then when we switch the inputs and the outputs, we get something that's not a function. You may also recall that one way to tell if a function is one-to-one is to do the horizontal line test. So if we can draw a horizontal line on the graph of a function that intersects the function in more than one place, then that function is not one-to-one and therefore does not have an inverse. Okay, with that information in mind, if we think about sine, cosine, and tangent, and in particular the graphs of those functions, would they pass this criteria? Well, let's take a look at an untransformed sine function, or sine wave, something like this. And hopefully you agree with me that this will not pass the horizontal line test, right? I could draw a line like that that will intersect it in many places. So it's not one-to-one and therefore does not have an inverse. And you would probably, hopefully, if you think about what the graphs of cosine and tangent look like, you would agree with me that those also do not have an inverse or are not one-to-one. So why are we even talking about this, Cody? Can we just skip this and go on to something else? Well, no. What I'm going to do now is redraw the sine function to look something like this. And again, as you point out, or as I pointed out, this is not one-to-one because I could draw a horizontal line there that would hit it in multiple places. But notice if I restrict the domain, and in particular if I restrict it to just this piece that I highlighted there in pink, does that part, just the part highlighted in pink, pass the horizontal line test? Hopefully the answer, or you're nodding your head saying yes, right? So that's one way we can deal with when functions are not one-to-one and technically don't have inverses. We can restrict their domains and then talk about the inverse of just that little piece of the function that we've restricted to, which is what we're going to do here. All right, so here is our next task, is we're going to switch over to the graphing calculator here in a second, and we're going to graph inverse sine and inverse cosine and inverse tangent. And we're going to look at what their domain and ranges are. Now, one word of warning I want to point out to you. When you see something like this, whoops, oh my goodness, here we go. When you see something like this, sine with a -1, cosine with a -1, or tangent with a -1, that means inverse. Okay? And so, be careful that we do not confuse that with something like this, 2 to the -1, which would be something like 1/2. Okay, that is not what we're saying there. We're referring to the inverse function. Now, the reason I point that out is because we know that if we have something like sine of x to the -1, that's the same as 1 over sine of x, which is cosecant. So you might think that to graph inverse sine, inverse cosine, inverse tangent, we could graph cosecant, secant, and cotangent. However, that is not the case here because those -1s are in a different place than they are here. Okay? All right, so let's switch over to calculator. And first thing I'm going to do before we start graphing these is change our window. So right now I've got the window set up for the window we use to graph our sine and cosine functions. And note that this -6.28 is the same as -2 pi. And the 6.28 is the same as 2 pi. And then this 1.57 is pi over 2. Okay. And when we're going to set up our window to graph the inverse trig functions, remember that inverses swap inputs and outputs. And in the case of this function here, or in this way we have our windows set up here, that means we need to switch the x's and the y's. Right? So these numbers need to get reversed. So we're going to do that to set up our window. So I'm going to make my x-min -4, x-max 4, and then count by 1s there, since that's what we did in the y's before. And then for my y values, I'm now going to change those to what I had for x. So -2 pi, 2 pi, and then we're going to count by pi over 2. And again, we're doing this. Whoops, I don't know what I just plugged in. That was the wrong thing. We're doing this because inverses switch inputs and outputs. So it's going to change what is on which axis here. Another thing I want to point out is recall that when we had a function like f of x equals sine of x, remember that what we input into here were angles. Right, so we'd input like pi over 6 or pi over 3 or 5 pi over 3 or 8 pi over 3 or something like that. And what we output, okay, the numbers that would be output were ratios. Okay, so we'd get things like √3 over 2, 1/2, -1, 0, those sorts of things. So if we're doing the inverse, remember, it's going to switch the inputs and outputs, so these things will get switched now. So if we're graphing the function f of x equals inverse sine of x, then the inputs here now will be the ratios, since those were the outputs of sine. And then the inputs, excuse me, the outputs will be angles. I'm sorry, I'm running out of room here. Okay, so with inverse trig functions, we input ratios and output angles. All right, so let's go ahead now and graph the inverse sine function. So we're going to go to our y equals. Again, inverse sine does not mean 1 over sine. Okay, so to get the inverse sine button, what we're actually going to do is hit second. And we hit the sine button. Notice it gives us that sign with the -1. Input x. And now we graph that. And we see our graph of our inverse sine function. Now notice it's just a little piece of the graph, a little small piece of graph, I guess, for lack of a better term. Remember, the reason for that is in order to have an inverse of sine, we had to restrict the domain. Otherwise, there was not going to be an inverse. Also recall in the way that we set up our axes here, these numbers here are counting by ones. And then on our vertical axis now, we're counting by pi over 2. And yeah, put that here, here. Whoops, that was wrong. It should be negative pi. Okay, so let's now come up with the domain and range of inverse sine from this function. Well, for the domain, that's going to be the values it goes between on the horizontal axis. So notice it looks like, if we look at the graph, we're starting here at -1 and ending over here at, ooh, that should be a positive number, Cody, not a negative. There we go. Okay, so it looks like the domain of the inverse sine function goes between -1 and +1, and it does include those because remember the values of sine can go between those two values. And then the range, well, that is going to be bouncing between, looks like negative pi over 2 and pi over 2 are the top and bottom there. And again, I don't know why I made everything negative, I guess. Just really excited about negative numbers right now. So we go between, excuse me, pi over 2, negative pi over 2, pi over 2, and in this case, those are also included. All right. Cool, I'm gonna leave that there. What I want for you to do after this video ends is to graph inverse cosine and inverse tangent on your own calculator and use that to determine the domain and range of those functions. After you finish, you can go into the textbook and double check your work. All right, thanks for watching.